Hey everyone, in this lesson we're going to study end behavior polynomials. Okay, so there are key pieces that we need to look at on any polynomial so we can determine its behavior, its end behavior. So a sign, if it's a negative lead, will indicate the graph points down. So if the graph's going opposite directions, then you might have just like a line. If the slope is negative, this is what the graph looks like, right? And if it's a parabola, then the parabola points down. So that's when it comes to the sign degree. If the degree is even, then the ends stay together just like parabolas. So that means if the parabola opens up, then both ends point up. If the parabola opens down, then both ends point down. And if the degree is a number that is odd, then the ends go away from each other just like lines. Like here, this goes to the left and this goes to the right, or this goes up and this goes down. So the point is they go in opposite directions. And then the number of turning points, you find the number of turns by subtracting ones from the degree, the highest power, okay, which means you take the highest power degree and subtract one from it. So this is what's going to be new about this lesson. Notation, okay, so this is the new vocabulary you'll see in this lesson for today. So what this means is as x goes to negative infinity, where's y going? Is it going up or down, or negative infinity or positive infinity? And as x goes to positive infinity, where is y going again? Okay, positive or negative infinity. So that's what you'll learn to do today. So for example, as you can see, we have a parabola here. And as the values of x go to the negative infinity, which means the left, the y values go up, right? They go to positive infinity. And as the x values go to positive infinity, the y values go to positive infinity. So this will be the notation for today. So I'm going to look at this graph and say, as x goes to the left, which is negative infinity, by looking at the graph, I see that y is going up, which means it's going to positive infinity. So that's what this is asking. So where x goes to the left or negative infinity, where is y going? So y is going to positive infinity. Now the other, as x goes to positive infinity, okay, that's what this is asking. Where is y going? So the values of y going are going to positive infinity also. Okay, so that's what this means. So this is new notation that you'll be introduced to for this lesson today. So on the next few examples, we're going to state whether the function graph is a odd or even degree, and b, so that's a, and b positive or negative leading coefficient. And as you can see, this the graph points in opposite directions, so that means the degree has to be odd, okay, because they go in opposite directions. So degree is an odd degree. And b is the lead, positive or negative. So in this case, since we see that this points up to the right, then it has to be positive. If it's negative, the right side points down. And on the next example, as you can see, both ends point down, so they go in the same direction. So that means the degree has to be an even number. Okay, and since they both point down, then that means the lead is a negative lead. So to the right, we see that it goes down. So that right away tells you this is a negative lead. All right, on the next example, example number 3, first notice that the ends point in the same direction. So then that tells you that the degree is an even number. And then B, we see the right side points up. So that means the lead coefficient is a positive lead coefficient. Okay, example number 4, for this one. First, we notice that the ends go in opposite directions, so that tells us that the degree, the highest power, is an odd number. Okay, and then B, the ends, the right goes down, so that means the lead has to be negative. So negative lead. Now we don't know what that number is, but we know it's negative because of what the graph is showing us. So let's go on to the next part, and this one says for each function, say the degree. That's part A. Part B, say the maximum or minimum. Maximum number of turning points. And then C, sketch a picture of the parent function the ends will mimic. And then using infinity notation, describe the end behavior. And then E, sketch the possible graph with the maximum possible turns. So let's start with number A. Part A. Part A says state the degree. So we look at all the terms, and the highest power is this one here. So we see that the degree is 4. So the degree in this case is 4. And then B, say the maximum number of turning points. So we take the degree and subtract 1 from it, okay, which is what we said here. So then this graph is going to have 3 turns. And part C is asking for a sketch a picture of the parent function the ends will mimic. So we know that this graph has a degree that is even, so then it looks like a parabola. Okay, the ends point in the same direction. Part D says, using infinity notation, describe the end behavior. And let's see, so describe the end behavior. So in this case, what I'm going to do is I'm going to say the following. As x goes to negative infinity, okay, we have a positive lead coefficient, then that means the y goes, and this is just like a parabola, so y goes to positive infinity, okay, because we have a positive lead coefficient. And as x goes to positive infinity, we can tell right away, because since the end point in the same direction, then y also goes to positive infinity. So I'm going to give you a sketch for this in part E. So for part E, don't forget that the graph must pass the VLT, or vertical line test. Okay, so the graph of this function looks like this, kind of like this. So we know the ends point in the same direction, so as this goes to the left, y goes up. And then we know it has 3 turns, so it looks like this. There is 1 turn here, another turn here, and then another turn. So there are the 3 turns. At this point it pivots, and at this point it pivots again, and at this point it pivots. Okay, so this is what the graph for this problem should look like. Let's go on to the next example. So notice this one here, when you distribute, this is x squared. When you distribute this x inside of this parenthesis, this becomes x cubed, which means the degree of this polynomial is degree 3. Since we know the degree is 3, then subtract 1 from the degree, and that means this has 2 turns. And part C, sketch a picture. So we know this is 3rd degree. The ends they behave like a line, so they go in opposite directions. Okay, so I'm going to say that this graph looks kind of like this, like a line. The ends go in opposite directions. Part D, using this symbol here, I'm going to say as x, okay, as x goes to negative infinity. So first we know that there's a positive lead coefficient. So as x goes to negative infinity, y is going in which direction? Well, this is the right side, so then y should be going to positive infinity. Okay, not true, but to negative infinity. So this is going left, so that's this side here. And as x goes to positive infinity, notice this is going to positive infinity, then y also goes to positive infinity. So a sketch for this is, we know this graph has 2 turns, so then the graph behaves like a cubic graph, so it goes like this, then turns and turns again. So this one has 2 pivot points, or has 2 points where you can see the graph turning. Okay, and that's all for this example. Example number 3. So for number 3, the highest power is this one here. Okay, that's the highest power, so that means we have a negative lead. So first of all, let's state the degree, which is a stated degree. So this is degree 6. Number of turns, to subtract 1 from 6, is going to have 5 turns. And part C, sketch a picture. So since we know degree is even, then this graph, and also lead coefficient is negative, because this is negative, the graph is going to be pointing down. And it's going to behave like a parabola again because the degree is even. And part D will explain the end behavior of the graph. So as x goes to negative infinity, as you can see on the left side, y also goes to negative infinity. And as x goes to positive infinity, the graph keeps pointing down. So on this side, so that means y also goes to negative infinity as x goes to the right. And that's all for example number 3. Okay, example number 4, the highest degree, this is the highest degree. Okay, we have a negative lead, but the highest power is 5, so this is degree 5. Number of turns, subtract 1 from 5, so it's going to have 4 turns. And then part C, we need to sketch a graph. So this one, we know that on the right side, this should be pointing down, right? So it's going to look like this, points down on the right side, and then points up on the left side. So then this should help us state the end behavior of the graph. So as x goes to the left, which is negative infinity, y goes up, which means y goes to positive infinity. And as x goes to positive infinity, y goes to, it's pointing down, so y goes to negative infinity. Okay, so now let's sketch the graph for this. So we know it's going to have 4 turns. So the graph could look like this. We know on the left it's going to point up, something like this. Then it's going to have 4 turns. So then this goes here, turns, and then turns again, and then turns again, and then one more turn, and then points down. Okay, because of negative lead coefficient. So this one has 4 pivot points on the graph. And that is all for this lesson. I'll see you guys in class. Bye-bye.